Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Hi everyone, welcome back to Geeks for Geeks practice. So quickly give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine so that we can have a head start, right? All of you can give me a +1 and very good morning from my end. Okay, I'm good. Hussain, how are you? Okay, hi Shubham. Okay, hi Rishit. So regular POD viewers, like regular solvers of POD. Hi Vikas. Okay, great. So let's do one thing. Let's quickly share the screen. So I'll present my screen first of all. Okay. All right. So you can give me a +1 for this also if my screen is perfectly visible. I've shared it. Okay. So the problem of the day, okay, was prime sum. Okay. The name of the problem was prime sum. Now, what does this problem say first of all, right? You know what are prime numbers, guys? First of all, this problem is related to prime number. So you know what is a prime number? What is a prime number? A prime number is a number which has only two factors, right? Which has only two factors, that is one in itself. Let's say if you talk about 7. So 7 is a prime number. Okay. If you talk about, let's say 5 is a prime number. If you talk about 13, 13 is a prime number. If you talk about 17, 17 is a prime number. Correct? All of you can give me a +1. Now, what you need to do is, what you need to do in this particular problem is, you will be given a number n. Okay, you'll be given a number n. So you are given n. Okay, you are given what? You are given n. You have to tell what? You have to tell that. Can you express it as the sum of two prime numbers? Okay, can you express this number n as the sum of two prime numbers? Like you are given n, and you have to tell that can you express this as the sum of prime number 1 and prime number 2? Okay, is equal to n. Can you add two prime numbers p1 and p2 such that they are equal to n? Okay, now let's quickly look at into the examples. So if you will see 34, right? If you will see here, if you will see the example 34, so 34, for 34 you will say that okay, yes, the answer is true. Like if you will observe for 34, they are saying that for 34 you will write a yes. Okay, you will write a yes. Why? Because you are saying that if n is equal to 34, then there is a prime number p1 and there is another prime number p2 such that it is equal to n, that is it is equal to 34. Can you tell me what numbers I'll choose as p1 and p2 in this particular case, guys? Can you tell me that quickly? Can you tell me, guys? Can you tell me in this particular case? Can you tell me for 34 which prime numbers should be taking the sum? I think if I take 3 as one of the prime numbers, I think another prime number will be 31, right? Then I think that I can get the sum as 34, correct? I think 34 is also a prime number, right? This is one thing. Then maybe you can say that okay, so somebody saying that I can do this also. Yeah, 11 plus 23 also. If I'll do that, so 11 is a prime number, 23 is a prime number, so I'll get this particular sum as 34. There can be various combinations, right? So I'll write a yes for this particular case, right? Okay. Now, what can I try to do? What can I try to do? Can I say that? Can I say that? Basically, what do I want? I want x plus y, right? I want x plus y is equal to n, correct? I want the sum of two numbers to be equal to n, such that I want x to be prime, okay? And I want y to be prime as well, okay? I want x to be prime and I want y to be prime. Okay, Aditi Sethi is saying this thing. Great, guys. So you can do one thing for me. You can hit the like button if you haven't till now, and then we'll discuss the problem further as well. I can see the number of likes are a little less, so just quickly hit the like button if you haven't. Okay, so it says that basically what I can do is I can take two numbers. I want two prime numbers, x plus y, that is equal to n. Like that is equal to n. The sum is equal to n. Okay, so I am saying that what I can do, what can I do? I am saying that I will iterate, like if suppose that one of the numbers is I, right? If suppose that the first number is I, okay, then what will be the other number, right? If the first number, suppose first of like one of the prime numbers is I, right? Suppose that if one of the numbers is I, in fact, right? Suppose that one of the numbers is I, right? If I do I plus y is equal to n, suppose that I know I, so the second number will be what? N minus I, right? I am saying that I plus n minus I, okay, it is going to give me the sum is n. Are you getting this point, guys? So I need to find, like, I need to find that if there is a number I that is prime, and I n minus I is prime. If I is a prime number, okay, 34 is not prime. Yeah, 34 is not prime. That is Agam is saying. But you need to find that whether this number n can be represented as sum of two prime numbers. So 34 can be represented as sum of two prime numbers. Okay, 34 is not a prime number, but 34 can be represented as a sum of two prime numbers. Understanding, Agam, here, right? So in this particular question, you can observe one thing. You can observe this particular thing, that if I'll have x, is this clear to everyone? If I have x plus y, okay, is equal to this particular thing. Let's say x plus y is equal to n, right? Let's say x is I, the number x is I, right? So I, like, this thing I plus y is equal to n. So basically I'm saying that the second number y is equal to nothing but n minus I. So I'm basically saying that if one of the numbers is I, right, then another number is n minus I, right? If I take the sum, then I'll get what? Then I'll get the sum as n. So I need to check if there's a prime number I, right? If I is a prime number and n minus I is a prime number, right? I'll iterate from all the numbers from 2 till n, okay? Like, I'll iterate for all the numbers, right? I'll iterate for all the i's basically. I'll run a loop of I from 2 till n minus 1, you can say, till the last, because I want to run for the prime numbers. So if I'll have I as n, then the other number n minus n will be 0, and I don't want that. So basically what I'm saying is I can run from 2 till n minus 1, okay? And if there is any I, right, if there is like, if ith number is a prime number and n minus ith number is also a prime number, guys, okay, right? If like, if these two numbers are prime numbers, right, so in that case I can say what? If ith number is a prime number and if n minus ith number is a prime number, right? So in that case I can say that I have made the sum now, because the number I is prime, n minus I is prime, so their sum is going to be n. Is that clear to everyone? I'm going to run a loop. Okay, I'm going to run a loop and I'm going to check for every possibility. I'm going to check from 2, 3, 4, all the, like, for all the values of I. I'm going to check if I is a prime number and n minus I is a prime number. Is that clear to everyone? Just quickly hit the like button and give me a +1 in the chat. Is everyone clear with this particular thing? All of you are clear? You can write a clear in the chat, guys. Is everyone clear with this particular thing? Then I can move further. This basic thing, that basically what I can do is I can run a loop, right? I can run a loop, correct? I can do what? I can run a loop. Like, you can say that I starts from 2 till I is like, till, you can say, n minus 1 kind of thing. I can run till here. And if I is a prime number, right? And you can say that if n minus I is a prime number, right? In that case, I can say that I'll return a yes. Because if one of the numbers is I as prime and another number n minus I is also a prime number, so overall sum of these two numbers is going to be nothing but n only, right? Now, how much time will I take in this particular approach? So you can see, for checking if a number is prime or not, it will take me square root of n time, okay? It will take me, like, what I can do is I can basically run square root of n times for a particular number. Let's say if I want to check whether x is a prime number or not, suppose, or let's say if I want to check whether q is a prime number or not, so I'll run square root of q times for checking if it is a prime. Like, I will run till square root of n, and if there is any factors, then it is not a prime number, otherwise it will be a prime number, right? Is that clear? So for one, like, see, I'm running how many times? I'm running the loop n times. You can write n in the chat. I'm running the loop n times. So if in the worst case, if you'll observe, so for one like, for one particular value of I, right, for one value of I, I'm taking square root of n time to check if it is prime number or not. So if I'm running the loop n times in the worst case, so I'm taking n square root of n time for checking this particular thing, correct? Are you getting this point, guys? That if I is a prime number and n minus I is also a prime number, right? So since I'm checking for all the possible values of I, right, you can write all in the chat. I'm checking for all the possible values of I, correct? So since I'm checking for all the possible values, so I'm checking for this I, next I, all the i's, right? So for checking one of the i's, it will take square root of I time, you can say, right? So for checking for one I, so if I'm checking for all the i's, then that will take n into square root of n time, correct? So I should be a prime number, n minus I should also be a prime number. In that case, if this is true, then I'll return true, or you can say yes, correct? And this approach is going to take n into square root of n time. Is that clear to everyone? Rishit is clear to, is it clear to you? And other people, Hussein, is that clear to you? Guys, are you clear with this problem till now? My internet is buffering or what? Okay. Is it clear? If you're clear with this, then you can quickly write a clear in the chat. So this is what I'm saying. Like, see, if you talk about, let's say, if you want talk about any number, right? If you talk about any number, so in square root of n time, you can check whether it is prime or not. Okay, this is a property of it. If you don't know, so what I can do here is I can simply say one thing. I can simply say one thing that okay, for looping from I from 0 till this thing will do also do low times. It's come in my head little. Okay, you, if you want, you can apply those approaches as well. So what I'm thinking of is I'll write a function to check is prime. Okay, so I'll write bool is prime. Okay, bool is prime. This particular approach, in this particular approach, I'll write bool is prime, and then I'll pass the number. Let's say I'll pass the number as x. Okay, to check if x is a prime number or not. Okay, so what I will do here is I'll say that for, okay, like int, let's say I starts, let's say a value k, okay, starts from 2, and k is lesser than equal to, let's say, square root of x. Okay, this is what I will do, and I'll do k plus plus. Okay, and if it happens, right, if it happens that the x number x modulo k, okay, if it's equal to 0, if it is divisible by any number, right, if it is divisible by any number, if the number x is divisible by any number other than 1 and itself, in that case it is not a prime number. Like, so I'll return it as false. Okay, otherwise when I come out of the loop, so I'll return a true. Okay, this is what I'm writing in the is prime function. Now what I will do here is I'll simply say that for int I starts from 2. Okay, I is lesser than, you can say, n, and then I'll do an I plus plus here. All right, this is what I will be doing. Now I will check that if is prime, okay, if ith number is a prime number, and the is prime of n minus I, right? If ith is a prime number and n minus ith number is also a prime number. So if this is a prime number, okay, and the n minus ith number is also a prime number, right? If I is a prime number and n minus I is also a prime number, so total sum will be what? N, right? So in that case, I'll return what? I'll return yes, right? In that case, I'll return yes, that okay, it is a prime number overall. Is this part clear? If you are clear with this particular concept, then you quickly hit the like button and give me a plus one in the chat as well. Is everyone clear with this particular condition? For loop from 2 to this thing, we can tighten the range from 2 to n minus 2 also. Yeah, you can do this also if you want. Possibly, you can do this, like you can run it till n minus 1 also, because that is also going to be feasible, because yeah, you can do this also, right? So I'm running I from 2 till less than n minus 1, because if you will observe, like if suppose that one of the numbers I is there, right? If suppose that you are running, if you're running till n minus 1 na, so if this is n minus 1, then the other number will be 1, but you don't want that, right? So in that particular case, I think you can run it from here, or I think you can run it till lesser than n also, right? That can also be feasible. If that is not the case, right, like if you never like if there is no number I says that it is prime and n minus I that is prime, in that case you'll return a no here. Okay, so this is what I've thought. So you're checking for each and every I. So one time when you're checking, it will take square root of n time. Then for another I, when you're checking, it will take again square root of n time. So overall, for since we are checking overall for all the n values, so it will take n square root of n time. Okay, now let me try and do one thing. Let's quickly compile this code and see what will happen here. All of you can hit the like button if you haven't already, guys. Let's try and submit it as well to see if it gets accepted or not. Yeah, it gets accepted. So is this approach clear to everyone? You can run it from I starting from 2 till lesser than L also, that is fine. Is everyone clear with this particular approach? Rishit, your optimization is also really good, but I think this is another way that we can do it. From 2 till lesser than n, because you don't want the other number to be 0, right? So from I starting from 2 till lesser than n, you're running for all the numbers, and you're checking for if I is a prime number and n minus I is a prime number. So the total, like that will mean that these are two prime numbers, and since first prime number is I, second prime number is n minus I, so the sum of that will be a prime number, like sum of that will be n, and since both the numbers are prime, so I'm simply going to return a true, because the number n is the sum of two prime numbers. Otherwise, I'll return a no. Okay, then now I will discuss one more approach with you. Is this approach clear? If this approach is clear to everyone, or if you can give me a plus one and quickly hit the like button and give me a plus one, and then I'll proceed further to the second approach as well. Can we move further to another approach? Can we move further to another approach? Because if you will see here, now what was happening, my is prime function, okay, my is prime function is taking how much time? It is taking order of square root of n time, right? And I'm running I from 2 till the end of the array, right? You can say till lesser than n, that is n minus 1. So for one value, if I'm checking, so it is taking square root of n time. But if I'm checking in the worst case for all the throughout the loop, right? So that will take for n values, it will take n square root of n time. Okay, can we do something better than this? Right, can we do something better than this? Anyone has any suggestions? Yes, what we can do is we can simply use the sieve, right? Sieve of prime, you can say, or sieve of Eratosthenes, basically in this particular approach. Okay, can we start off with this approach, guys? What do you think? Can we start off with this approach? Okay, can we start off with the sieve approach for this particular problem? See, what we are doing is currently we are solving, right, in n square root of n time. Okay, currently we are able to solve the problem in square root of n time. But what we can do is now we can further optimize it using the sieve algorithm, and we can solve it in n log of log n time. Okay, by using the sieve approach. Okay, you can write okay in the chat, and then I'll explain this particular approach to all of you as well. Just quickly write an okay in the chat so that I can understand that everything is working fine. And if you haven't hit the like button, you can also hit that. Okay, so what I will be doing here is now I'll say that I will pre-compute. Okay, Sieve algorithm does what? It pre-computes all the prime numbers, right? Pre-computes all the prime numbers. Now, what do I mean by that? So by this particular thing, okay, itself is logarithmic operation. Won't it take? Yes, that is what. Yeah, in this case now, what you can do is you can also do one more optimizations. If see, you can do one thing, like you can do it like two ways. See, if you want to write it like I is lesser equal to square root of n, there are two ways. You can write it like this, okay, but you can also write it like this, I cross I. You can basically say that you can multiply with like, see, this is what, like I am saying that this is what, like mathematically, if you'll understand, obviously, so I is lesser equal to square root of n. If you think that, okay, you can do what, you can do I into I, okay, is lesser equal to n, right? So you can write it like this also. So here you can do one optimizations. What you can do is you can say that k into k is lesser equal to x. That is also another thing that you can do, obviously. Yes, so Abhigyan, your approach is also right, but basically you need to understand this thing, that if you have, like, if you multiply, like basically this is what, this is nothing but I square. If I square is equal to n, then you do what, I is equal to under root of n na? So basically, if you don't take the under root, like, then this will be the scenario. So that is why I into I is lesser equal to n also. This can also be written. Is that clear to everyone? Is that clear to everyone? Okay. Now talking about the other thing, like talking about the sieve approach, Rishit, I'm not sure whether I'll have that much time to discuss the this approach of square root, because I have to discuss the sieve approach as well. So I'll see if I will have time, then I can discuss. Otherwise, we might have to skip that approach. Okay. So see, what we do is now we will take an array, like, so let's say we take an array 2, 4, 5, 6. Okay, we'll have the numbers till n. So suppose we are having the numbers, okay, like let's say we have 11, then we have 12, then we have 13, then we have 14, then we have 15, then we have 16, then we have 17, then we have 18, then we have 19, then we have 20. Okay, suppose we have this particular thing. So initially what we will think is the, like, we will try to do what, we'll try to build an array here. Okay, so we'll remove this particular function from here, and what we will try to do now is, what we'll try to do now is we'll try to pre-compute. Okay, so we'll do what, we'll say that okay, is prime, okay, we'll say that is prime of I. Will, like, this array will tell us whether this number is prime or not, right? This particular, like, we will store in an array true or false. So basically what I'm saying is prime. Okay, we'll not write it as a function, but basically now we will write it as a like array. Okay, so if ith is a prime number and n minus ith is a prime number, this is what we are going to try and do. Are you getting this point, guys? Is everyone getting this particular point? Let me see the responses in the chat. All right. So see, what we are going to do here is we are directly going to, like, we are going to do this in order of one time, right? We are going to check whether the ith number is a prime number or not, and the n minus ith number is a prime number or not, in order of one time. Okay. How? because we will do what? We will basically pre-calculate. Okay, we'll do what? We will pre-calculate. We'll do what? We'll basically try to pre-calculate this particular thing. But how will we try to pre-calculate this particular thing? So what I can say is now, initially you will do what? Initially you will do what? You will declare an array. Okay, let's say you will declare an array. Let's say bool, okay, is prime. You can do what? You can declare an array bool is prime of size n, and you can initially mark every state as, let's say, false. So what you can do is you can basically run a loop, let's say, and you can say that I starts from, let's say, 1, or you can start it from 2. You can say that I is lesser equal to n. Okay, like I is lesser than n basically, and you can do an I plus plus, and then what you can do is you can say that is prime of I is equal to true. Okay, so you'll mark every number as prime. Okay, initially what you will do is you will mark every number as prime. Is that clear to everyone? Is that clear to everyone? You can write every in the chat or plus one in the chat if you are clear with this particular thing. Initially you will think that every number is a prime number. Okay, since a lot of people are watching, I'm highly requesting that if you can hit the like button, that will be great. So initially you will do what? Initially you will choose every number. Like initially you will say that every number is a prime number. Okay, so initially you have marked every number as true. Is that clear? Then I'll proceed further. Initially what you will do is initially you will mark every number as a prime number. Okay, now what you will do is you will run a loop. So you'll say that, okay, for int I start from 2, and let's say I is lesser. Okay, thanks a lot. Thanks a lot. Okay, so now what will I do going further, right? That is the condition. So now after marking every number is true now, so suppose I'll iterate on this particular number, right? If I iterate on 2, right, if I am at 2, so if, understand this thing, understand this thing, if 2 is a prime number now, if 2 is a prime number, then what can I say? If 2 is a prime number, then what happens? If 2 is a prime number, then is 4 like, see, if 2 is a prime number, right? So I am saying that, suppose that I'm running a loop. Okay, suppose that I'm running a loop. I'm not defining till where I'm running it, but if I is a prime number, right? So is prime of I is equal to true. Okay, if I is a prime number, guys, then can I say that all the multiples of I will not be prime? All the, right? Voice is a little low. Okay, so I'm saying that if I is a prime number, then all the multiples, okay, all the multiples of I are not prime, not prime, right? Because if you will see here, if 2 is a prime number, no, so can I say that I'll mark 4 as false, right? I'll mark 6 as false, I'll mark 8 as false, I'll mark 10 as false, I'll mark 12 as false. Are you getting this particular point, guys? Is everyone clear with this particular point? All the multiples, if ith number is a prime number, then all the multiples will no longer be prime. So I'll mark them as false. Is that clear? Is that clear? So basically what I'm saying is, if I is a prime number, then starting from 2 into I till the end, all the other numbers are not going to be prime. Is this particular fact clear to everyone? Just quickly let me know. I'm looking at the chart for this. Is everyone clear with this particular thing? Okay, now see guys, understand this thing, right? If 3, suppose that if 3 is a prime number now, then 6 is not a prime number, right? Then 6 is not a prime number, correct? You can write yes in the chat. If 3 is a prime number, then 6 is not a prime number, 9 is not a prime number. But do you really want to mark 6? Do you really want to mark 6? Because 6 is already marked as false by 2. 2 has already marked 6 as false, because if 2 is a prime number, then 6 is not a prime number, right? So if 3 is, you can say that you can start marking from 3 into 3, right? You can start marking from 3 into 3. You can start marking directly from 9. Why? Because if you'll observe one thing, now let me write something for you. Okay, let me write something, and then you will understand why I'm saying this particular thing. So what you can observe here is that if I'll take it like this, let's say if I write 21, 22, okay, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so if 2 is a prime number, then 4 is not a prime number, 6 is not a prime number, 8 is not a prime number, okay, 10 is not a prime number, 12 is not a prime number, 14 is not a prime number, 16 is not prime, 18 not, 20 not, 22 not, 24 not, 26 not, 28 not, 30 is not a prime number, correct? This is what you are doing. But after this thing now, like, does 3, like 3 into, like, see, if I is 3, then 6 is not a prime number, 9 is not a prime number. But do you really want to start from 6, or you want to start from 9? Because 6 is already marked as cancel, right? So you want to start from 9, correct? Because if you will see, let's say 3 will mark 6 as false, maybe, right? But actually 3 needs to start from like 3 should start marking from 9, because 6 is already marked as false, right? So you'll mark this as false, right? Then you'll mark 12 as false, right? Then you'll mark 15 as false, then you'll mark 18 as false, let's say. Then 21 will be marked as false, right? And then 27 will be marked as false as well, right? And 30 will be marked as false. Now if you will see now, is 4 a prime number? No, 4 is not a prime number, right? So I'll skip 4, then I'll be at 5. So now tell me now 5, if you will talk about this particular number, right? If you talk about this particular number 5, right? So you can see that 10 is already marked as false, right? You can see that 15 is already marked as false. You can see that 20 is already marked as false, right? You can see that now 25 needs to be marked as false, right? So you can see 10 is already marked as false, 15 is already marked as false, 20 is already marked as false. So I need to start from where? I need to start from 25, right? So if I is a prime number, then I need to start from I into I need to start marking from I into I. Please write I, like I into I in the chat if you're clear with this particular thing. Is everyone clear with this particular fact? Very basic, to be honest. Is everyone clear with this particular fact, that I need to start from I into I? Because I don't want to mark 10 again, no? Yeah, for yeah, we need to start from I into I. So what I'm saying is we can do what, all the prime numbers. If I is a prime number, then what I can do is I can simply say that I will start a j, okay, from I into I, okay. J is lesser than n, and then I'll do a j plus plus, not a j plus plus, sorry, j plus is equal to I, because I'll do for all the multiples now. You can write j plus is equal to I, right? So that is what I'll do. And what I'll do is, if like basically I'll say that is prime of okay, is prime of j is equal to false, right? So I'll mark all the multiples as false. You can write f in the chat. I'll mark all the multiples of it as false. Is that clear to everyone? Is this particular fact clear? Right, this is what I'm going to do. And I can simply say that I'll be running till where, right? So you will understand one thing, you will understand one thing, right? If I take a bigger example, right, if I take a bigger example for all of you, so let me do one thing, let's build it more. So if I'll write some more numbers, right, so if I'll write 31, okay. So where should I, till where should I run this particular loop now? Like, see, I'll always do y plus plus and all that stuff, right? That is fine. But till where should I run? So see, 32, 33, 34, okay, I'm writing 35, 36, then I'll write 37, then I'll write 38, then I'll write 39, then I'll write 40 as well here, then I'll write 41 here, 42 here, 43 here, 44, okay, 45, 46, 47, 48, 49, 50. Suppose that I have the numbers till 50, okay. So you can observe one thing, right? You can observe one thing, that all these numbers will be marked as false by 2 only, right? These numbers will be marked as false by 2, right? These numbers, right? These numbers will be marked as false. Then 3 will mark which numbers as false? So 3 is marked till 30, 3 will mark this as false, 3 will mark 39 as false, 3 will mark 42 as false, 3 will mark 45 as false, right? So 3 will mark all these numbers as false. Then 5 is there, right? So 5 will start from where? 25. So 25 is marked as false, 30 is marked as false, 35 is marked as false, 40 is marked as false, 45 is marked as false, and 50 is marked as false, right? Now which is the number, right? You can see 7, right? 7, right? 7 is another prime number, right? 7 is another prime number. You can see 7, right? Now 7 will mark which number as false? Will 7 mark 14 as false? No, 14 is already marked as false. 21 is another multiple of 7. So it is already marked as false. So you can see here that after that 28 is already marked, right, as false. 35 is already marked as false, right? So you can see that 41, like, okay, 42 is already marked as false. So I need to start, like, I need to mark this, right? 49, right? So I'll mark it. After that, do I need to mark any other number as false? Like, after that, is any other number marked as false? Because for eight, what is the scenario? For 8, the next multiple is 64, right? So that is not present. So basically I can say that I need to run I into I is lesser equal to n. Is that clear to everyone? I cross I is lesser equal to n. I need to run till square root now. I need to run till square root. Basically, if I will see, so I into I is lesser equal to n, because if n value is 50 now, right? So if I is 8, so 8 into 8 is lesser equal to 15, no, right? So I need to run it till where? Like, please write 7 in the chat. Now 7 into 7 is lesser equal to 50, so I need to run till here, because this is not possible. So I don't want to run till there now. So that is why what I'm saying is, I am saying that I will write it as I into I is lesser than equal to n, you can say. Is that clear to everyone? This is what I'm thinking of. Is this particular portion clear to everyone? You can just quickly let me know in the chat, okay. Now let me try and do one thing. Let's quickly try and compile it and see if we had made any errors or does it work. Okay, I have not declared the G, so I should declare it. Then I'll derive the time complexity also for it. If you are clear up till now, then you can hit the like button, guys, and you can let me know also. Okay, so it says that the token was not declared. Which token? Okay, J starts from I into I. No? Okay, let's see again. All right, yeah, it works on the samples. Let's try and submit it also. Okay, it gets accepted, right? You can write AC in the chat. You can write AC in the chat. This approach also gets accepted, right? You can see this particular approach, right? This particular approach also gets accepted. Basically, initially I marked every number as true. Then starting from 2, like till I cross I is less or equal to n, because I have told that if n value is 7, right? If sorry, if n value is 50, then you need to go till 7 only, na? Because 7 will mark, like you will start, like you will mark 7 into 7 as false, 49 as false. But if you go to 8, then 8 will be marking 64 as false. So you don't want to go till 8. So that is why you're going I cross I is lesser equal to n. Okay. Sir, can I ask you another question from GFG? Yes, you can. In the chat after this video is over, you can ask me and I will reply to that, or you can ask me that question on LinkedIn as well if possible. Okay, so if ith is a prime number, then all the multiples of I are not a prime number. So I'm marking them as false. And in this case, when how much time does it take to fetch the elements from an array? Order of one time, no? Order of one time, right? So basically, this is already stored. With respect to this particular element, with respect to the particular index, it is already stored whether it is a prime number or not. Here also it is stored. So this will take order of one time. So if ith is a prime number and I minus 1th is a prime number, I'm simply returning a true, like yes, otherwise I'm returning a no in this particular case. Okay, now talking about the time complexity of this approach now. So what am I doing here, right? So if you will understand now, this is nothing but the sieve algorithm. For this particular problem, this is nothing but the sieve algorithm. And what can I say about the sieve algorithm? I can basically say one thing. Like how many times it is running in the worst case, right? So if you will talk about 50 now, 50. So how many times it is running for 2? Can I say that when I is equal to 2, so it is running for, you can say, 2 4 6 8, like 2 4 6 8 10, correct? It is running for the multiples of 2, correct? If I is equal to 2, then it is running for all the multiples of 2. What do you think, guys? Is everyone clear with this particular thing? Right, it is running for all the multiples of 2. So how many multiples of 2 are there till 50? How many multiples of 2 are there till 50? Can you tell me? How many multiples of 2 are there till 50? Anyone can tell me that? Okay, total 25 multiples are there, na? So that is nothing but, if n value is 50 here, so that is nothing but n by 2 multiples are there, right? Okay, it will run n by 2 times. Now if you will talk about 3, right? So it will run, suppose it runs from 3 6, right, 9 12, right? The multiples, right? How many multiples are there in the worst case? You can say that n by 3 multiples. Yeah, n by 3 multiples are there. Okay, till n, there are, like, all the multiples of 3 are nothing but n by 3. Now you'll not run for 4 because 4 is not a prime number. Then for 5, n by 5 multiples are there. For 7, there are n by 7 multiples, and so on and so forth, right? This is the equation that I have developed. Okay, now let's do one thing. You will do what? You will take n as common from here. So when you take n as common, what is the equation? The equation looks like 1 by 2 plus 1 by 3 plus 1 by 5 plus 1 by 7. Okay, these are all prime numbers. Okay, now this is what, this is kind of a series, you can say. You must have studied in your 11th and 12th, right? This is kind of a series, which you can like, for which you can find the formula, right? So if you will solve this particular series now, like, see, if I say that, okay, like if I say that there is a series, right? If I say that there is a basic series, 1 plus 2 plus 3, like this kind of series up till n, then you will tell me that, okay, the sum of this series is going to be n into n plus 1 by 2, no? Correct, n into n plus 1 by 2. So similarly here also, when you have this particular series, right? When you have this particular series, so it also has a formula to it for calculating, and the formula for this series is nothing but log of log n. Is that clear to everyone? When you will solve this using integration and other things mathematically, then it will come out to be log of log n. So what you can understand is this n is already multiplied outside, right? This n is already multiplied outside, and the internal series here, its sum is nothing but log of log n. So the complexity now boils down to n log of log n. Is this particular part clear to everyone? This should be clear. That is why I have taken this particular approach here. Is it clear? All of you can hit the like button and give me a plus one if you're clear with this particular approach. Is everyone clear with it? Okay, that is nothing but the sieve algorithm for solving, and it is much more optimal because if you will see, now see that this was what n square root of n, right? Earlier, like earlier, when I solved it earlier, it was coming out to be this, but now I have further tried to optimize it to what, n log of log n, right? Now understand this thing. Now n is the same here, so this will not have an impact, right? This will not have an impact. Now you have to compare between the functions, right? So if you will see now, square root function behaves like what? If you will see, square root function behaves like this, right? Square root function behaves like this in terms of graph. But if you will look at the logarithmic function, no, so logarithmic function is quite slow compared to that. And when you're taking logarithmic of log n, see, square root function, square root of n is greater than logarithmic of n, right? But but this is not even logarithmic of n, this is log of log n. So square root is greater than square root of n is greater than log of log n, right? So basically logarithmic log of log n is better, so n log of log n is overall a better time complexity according to the situation. Is that clear to everyone? No problem, Joel. No problem. If you are late, you can obviously watch the recording at 2x. Okay, is that clear to everyone? Overall the concept is clear to everyone? Please let me know, guys. Are you all clear with this particular concept and the problem of the day, right? This question, I'm not sure, it was asked in Zoho. Okay, and it has C concept to it. Is it clear to everyone? This is what I've done. Again, summarizing. Initially, I've marked all the numbers as true. That is, I'm considering all of them as prime. And then I'm iterating for all the numbers from I till square root of n, you can say. And if ith number is a prime number, all the multiples are not prime, so I'll mark them as false. And in order of one time, I'm now checking, and I'm simply returning a true, right? Yes, otherwise I'm returning a no. Okay. So did you understood this particular problem? Because I've never been. Okay, no problem, because you're busy in my college assignment. No problem. Okay. So just you can just quickly let me know if you understood this particular problem or not. In general, we are computing. Should the upper range of space be this much? Basically, you are saying that should the upper range of space be this much? Yeah, you can say that whatever is the value of n, but again, if that is helping you to optimize in space, so that is why you can take some, you are obviously you are taking order of n space here, but it is not an issue in this particular problem. So suggest a book for algorithm. I can say that Geeks for Geeks and internet in general is very good for solving algorithmic problems. You don't need to solve it, like you don't need to buy any books as of now, right, on the internet. Okay, so overall, did you understood everything, guys? You can give me a plus one again if you understood most of the part. Like, did you learn the Sieve algorithm? For those who learned the Sieve algorithm as well, they can quickly tell me, and then we'll end the stream as well. Is that clear to everyone? Just waiting for your responses in the chat, and then we'll end this stream in 1 minute. Okay. Scope. So you can do one thing. You can send me the NCR problem in the chat. Okay. I am unable to solve GFG problems without space and time complexity, sir. So I will say that you can do one thing. You can try to practice it a little bit, and that will be more optimal. Can I post my solution for the first approach? Yes, you can obviously post your solution also. Detailed description, that will be fine, and you can post it in the GFG discuss section as well. Thanks a lot, Hushan. Thanks a lot, others also. So thanks a lot everyone for joining, and make sure to solve the problem of the day, right? Because if you will see here, now the new problem of the day here that we are having is this one. That is the maximum substring sum after k changes. So it has been asked in Amazon. Okay. So this is a kind of medium problem. So try to solve this particular problem. It has been asked in some good companies. Okay, and this was it from my side for today. Thanks a lot for joining. I have a time constraint, so I had to tell the main approaches. That is why I could not optimize it further, because otherwise the stream will be too large. Good morning, right? Yeah, good morning. So thanks a lot everyone for your time, and make sure to be consistent. And again, I'm insisting, solve this particular problem. Abhinav will be taking the live stream for this problem tomorrow, but make sure to solve it before and then come to the stream. Okay. So thanks a lot everyone for joining, and let's meet on Monday. Bye everyone. Take care. Good night. All the best and keep coding. Keep coding, guys. Bye.